Okay, from this video I'll show my answers of structured type, my second model paper, which is already published in my YouTube channel. Those are newcomers, subscribe first and you can see the model paper available, the previous video of mine for advanced maths. Already finished one structure paper and discussion also. So the subscribers, I hope you have already complete these problems and will see, check with me the explanations and the works, how the solutions here. Okay, as usual, first question, using the mathematical induction. Using the mathematical induction, prove that series notation, series answer. 1 over 1, 1 plus 1 over 1 plus 2, plus 1 over 1 plus 2 plus 3, and so on. Final term 1 over 1 plus 2 plus 3 plus up to nth term summation equal to 2n over n plus 1. Is a familiar problem for any pure mathematics structure. First problem is under the mathematical induction proving. So you know there are 3 steps of proving mathematical induction. First you show for n equal 1 true. So first point, if n equal 1, what is left hand side? LHS 1. See what is right hand side? RHS. Here in the answer put n for 1. 2 times 1 over 1 plus 1. That is 2 over 2. Therefore 1. So what? Therefore LHS equal to RHS. Both sides same. Then write a sentence that is, the given statement is true for n equal 1. That is, the given statement is true for n equal 1. What is the next point? Write this. Assume that the statement is true for n equal p. P is a positive integer. Assume that the given statement is true for n equals small letter p, where p is integer, positive integer, right? So therefore for n equal p, let's say copywriting, show copyright up to p, write show as a p. 1 plus 1 over 1 plus 2 plus 1 over 1 plus 2 plus 3 and plus 1 over 1 plus 2 plus 3 plus n for p up to p term summation. The answer is what? Put n for p. 2p over p plus 1. Okay, let's try the copywriting, right? Put n for p. Next point. If n equal p plus 1. If n equal p plus 1, we show what happened in the answer. So add this up to p plus 1's term and show the answer. What the answer be? To be. After simplifying the answer to be what? Put n for p plus 1. 2 into p plus 1 over p plus 1 plus 1. You'll show like this. Simplifying up to p plus 1 summation. Okay. So put n for p plus 1. 1 plus 1 over 1 plus 2 plus 1 over 1 plus 2 plus 3 plus up to p terms, plus what? Additional is what? P plus 1's term. So first term is 1 over 1, second term is 1 plus 2, third term is 1 plus 2 plus 3, 100 term is 1 over 1 plus 2 plus 3 plus up to 100. So p plus 1 over similar fashion, 1 over 1 plus 2 plus 3 plus 4 up to p plus 1, up to p plus 1 summation. Okay. So if you covered many this type of induction problem, you know the method. Wherever we use the n equal p plus 1, you need the assumption to implement here. That means up to p terms, up to p summation, 1, 2, 3, up to p term summation, you know the answer. 2p over p plus 1 2p over p plus 1 plus this n plus 1th term addition, p plus 1th term start from 1. So what is that? 1 over. So if you know the simple series formula, 1 plus 2 plus 3 plus up to n, what is the formula for n number summation? N by 2 n plus 1. N by 2 n plus 1. 10 number summation start from 1. 10 over 2, 10 plus 1, or 11. So here p plus 1 summation is n by 2, therefore p plus 1 over 2, n plus 1, n for p plus 1 plus 1. That's all. So by simplifying this, show this answer. So before finally you can leave a step and see the answer is what to be shown. Then you can go to that, approaching that answer. Therefore simplify this. So I show here 2p over p plus 1. I simplify here, 2 goes up, is 1 plus 2 over, what is that, p plus 1, p plus 2. Okay, p plus 1, p plus 2. So what is that, simplify here using the LCM, p plus 1 and p plus 2. So take the 2 also out, take the 2 out and simplify here, will become p into p plus 2 plus 1, is it? Okay, then what? 2 into p square plus 2p plus 1 over p plus 1 p plus 2. So that's equal to 2 into, this can be factorized, binomial, p plus 1 all things square, p plus 1 all things square over p plus 1 into p plus 2. So see what happened, 1p plus 1 here cancel. So 2p plus 1 over, what is p plus 2, can I write that? P plus 1 plus 1. See, we have the original expression, original answer. If we apply n for p plus 1, but to b, that is here. Therefore, it's true for n equal p plus 1. But the given statement true for n equal 1. Therefore, we can finish a sentence for every integer p, every integer n value. This is true. Every integer value and positive integer value and the given statement or formula is true. That is induction method. Okay, say second question. That is the inequality form using if the solution set of x which satisfy the inequality. Here the equation is given x plus 2 modulus less than or equal ax plus b. The solution set is given between 1 and x. Between 1 and 6. Between 1 less than or equal x less than or equal 6. The solution is given, therefore find the a, b values. Usually problems are, they will give the equation. We have to draw the graph or another method. We will find the range is what, boundary values of x is what. But here boundary is given, range is given. We find the a and b. So therefore the idea is we draw these two graphs. The graphical method is easy, right? Draw the sketch and we see where the both cuts and go to the answer. So if I take this is I write here y equal x minus 2 modulus. How to draw that modulus graph? Modulus has two parts, positive side and negative side, depending on the x minus 2 greater or equal to 0, otherwise x greater or equal to or less than 2. So if I take if x greater or equal to, then what happened? It's positive. This is positive. Then y equal x minus 2, x minus 2. Other one, if x less than 2, x less than 2, this is negative. If you know the modulus is negative, y equal what? You put a minus, additional minus, and write the expressions as it is. So y equal minus x plus 2. This is the graph to the first and the other side in equality form. Now if you draw this graph, so two parts depending on the x equal to, if I mark somewhere the x equal to, x equal to 1 is more than 2, 1 is less than 2. This is more than 2 graph, y equal mx plus c. If x is 0, y cuts minus 2. If y is 0, x is 2. So if you can draw this part like this, that's the part y equal x minus 2. And if x less than 2, x become less than, behind of 2, negative side, the same graph reflects minus x plus 2. Somewhere here like this. Okay, this becomes plus 2. This is the graph called y equal minus x plus 2, right? Minus x plus 2. That is how it can be plotted. As usual method, you can draw that graph, right? How the other graph, y equal ax plus b. Y, you can say like a y equal ax plus b. So here we don't know what is a and b. So we draw roughly, we draw the graph. Yeah, like we don't know what is a is positive or negative, whatever. So y equal mx plus c pattern. Therefore, for this problem, you need good experience of working such linear inequality problems. Then the both graph cuts, they are the solution. Therefore, this y equal ax plus b graph must be cut these two parts. Therefore, I do something like this. So my graph y equal, I take like this ax plus b, right? Y equal ax plus b. Y equal ax plus b graph. So now they say this is the greater, this part is larger, this part is larger than the other part. Then this green color I drawn, that graph should be upper than the other black color I drawn, these straight lines. Okay, this y coordinates are the bigger than this y coordinate. It's the biggest y coordinate. Therefore, that portion should be above than the other earlier what I drawn. Therefore, it's very clear. This portion is the answer. This part is the answer. This y values are larger than this y values. This is up, the other parts are down. Here what happened? Like this graph is up, this is lower. Here this is up, this is lower. But we need this graph is the highest value of the y. Therefore, in this case, these are the coordinates they provide. This is 1 and here 6. They said the inequality hold true for, satisfy for x equal between 1 and 6 also equal there, right? So these are the two coordinates. Now we solve and find the a and b value. So how you found this answer in other ordinary problem of the inequality or any linear graphs? If you solve these two equations, this coordinate, x is known. If you solve these two equations, this coordinate, y is known. So we solve. So if you solve these two equations, this and this I solve it. Y equal minus x plus 2 and y equal x plus b for x equal 1. If x equal 1, we can solve this pair of equation. So put x for 1, y equal minus 1 plus 2. Okay, that is 1. Let's say number 1. Here put x for 1, y equal a plus b. I say second. So connect the both, we'll obtain pair of equation. Connect the both. Plus b equal to 1. A plus b equal to 1. Well, both y equal. A plus b equal to 1. If I say my third equation. Now take this pair. Now take this 2 and solve. This 2 graph and solve to find the 6. So same idea. This 2 solve. This 2 graph solve. So y equal ax plus b. And that part y equal x minus 2. That solution is becomes when x equal 6. When x equals 6, what happened? What are the y value? Both y's are equal. So put x for 6, therefore 6a plus b equal 6 minus 2, that is 4. That is 4. I said my fourth equation. Therefore, I hope you work this. Check with me. When confused, we correct it if any problem. So now you solve these 2 equations. You can find the a, b value. Simultaneous equation. If you subtract, b cancel. 5a equal to 3. 5a equal to 3. Therefore, a equal to 3 over 5. And also you can find the b answer. I hope you can, right? That's the method, right? Next, limit question. Limit x tends to 1 minus square root x over 1 over a cos inverse x all things square equal 9 over 4. So they found this answer when x tends to 1, they found the answer is 9 over 4. So what is the a value? A is a positive constant. So what the idea? What is limit question? If you apply x for 1, if you substitute x for 1, what happened? Numerator is 0, 1 minus 1, 0. What is cos inverse 1? Cos naught is 1, cos 90 is 0. So here if you put x for 1, this is become the same, 0 over 0. Cos naught is 1, here not. So 0 over 0, indeterminate form or meaningless form. Therefore use any other method of simplifying this limit question. Answer is provided, find the a value. Okay, so the problem is inverse. We have a rare question, the inverse pattern. So we use a proper substitute. I mentioned many problems in the previous videos, previous model paper also. Cos inverse cos theta is theta. Tan inverse tan theta is theta. So therefore I take that substitute for a pattern. I take x equal cos theta. Let x equal cos theta. Therefore, all the problem now should be changed to in terms of theta. Very first change, if x is 1, what is theta? Limit change first. If x tends to 1, cos theta, what tends to 1? Therefore, theta tends to 0. Theta tends to 0. If x is 1, means theta is 0. Okay, therefore, limit x tends to 1 means theta tends to 0. 1 minus square root x4 cos theta over 1 over a is a constant and cos inverse x4 cos theta equal to 9 over 4. Okay, this pattern. Now we simplify. Limit theta tends to 0, 1 minus square root cos theta and 1 over a, what is this, cos inverse cos theta is theta into theta equal 9 over 4. Now the irrationalized model, if you work by any question, square root pattern, better you remove the square root by using the conjugates, multiple up and down by the numerators conjugate. So limit theta tends to 0, 1 minus square root cos theta multiplied by what? 1 plus square root cos theta, 1 plus square root cos theta up and down, or above and below, numerator and the denominator. 1 plus square root cos theta is equal to 9 over 4. So what? Limit theta tends to 0. But this factorize, where you use the conjugate method, it become a minus b, a plus b pattern, the factorization. So 1 minus cos, 1 plus cos, that is 1 minus cos theta, square root vanishes, over 1 over a theta into 1 plus square root cos theta equal the answer 9 over 4. Now come to the trigonometric limits. The main part is sin theta over theta form, or really tan theta over theta pattern. And now we can rearrange this to sin theta over theta pattern. Sin theta over theta. Also I can multiply this 1 over that side, right? So how to connect the cos double angle formula? Cos 2 theta, 1 minus 2 sin square theta. Cos 2 theta is 1 minus 2 sin square theta. Therefore 1 minus cos theta is what? 2 sin square theta by 2, okay, over theta into 1 plus square root cos theta equal 9. If I cross multiple, 9 over 4 is it? Okay, 9 over 4a, right? And now here rearrange the sine general pattern. General form of a limiting for sine, that is 2 sine square theta by 2. Therefore below also there should be a theta by 2. Okay, the answer is a square form, therefore I say the square, because sine square theta by 2, then below theta by 2, that also square, right? And see any other additional term now. 2 is available, sine square available, theta square available, and 1 plus cos theta. Is it okay, the method 1 over theta? Theta square, the problem is theta, all things square, no? Problem given question theta square means I check that theta square, theta square, theta square. Check that problem is theta square. All things square, no, cos inverse theta square, right? Therefore theta square is okay. This 4 is available additional. To remove that 4, I write here 1 over 4. So 4 cancel everything, okay, right? And here therefore 1 over square 1 plus square root cos theta equal 9 over 4a. So solve that equation by apply the limit what? Theta 0, limit theta tends to 0. So apply the values 2 into sin theta over theta 1 equal 1 into 1 over 4 into cos naught is 1, square root 1 is 1, 1 plus 1 2 equal 9 over 4a, 9 over 4a. Now find the answer. Say here 2 cancel, here 4 cancel. I missed that a square, say I missed that a square, check that a square, check that I missed the a square. So it becomes a square equal to 9, therefore a equal to plus or minus 3, but they say is a positive answer, therefore a is plus 3, a is plus 3. So I hope you complete it. Check, I made a mistake, theta square and a square, continue that, otherwise different solution, you can't do that, theta square is important. Next problem 4 is a binomial part. The term independent of x in the binomial expansion of 2x minus 1 over 3x to the power n, 2x minus 1 over 3x square to the power n is 240 over 9. Is 240 over 9. So find the n value. But the question, the term independent of x in that binomial expansion is 240 over 9. That means what? If you expand this long expression, there's a term, on that term there's no x. Independent of x means there are no x part, no x square, no x cube, or no 1, no x to the power something, only a constant value. Therefore actually that is a constant term. Independent of x means that's the constant term. So they said the constant term is 240 over 9. Therefore what is the power to be expanded? So such a case we find the general term of this binomial part and continue to that equation to find the n value, right? Therefore here write this common term of the expansion or general term. General term tr plus 1, right? Generally we write like a tn plus 1. Here we call tr plus 1 is a general term. So how to write the general term of a binomial expansions? NCR, and the first term n minus r, and here minus 1 over 3x square, its power this r, the general form how to expand a binomial thing, right? NCR, this 2x n minus r power, and the other term power is r. Now we simplify it. The main part is x to the power is what? Now we have to find which term is r. R belongs to what? Which term is the power comes without x, no x in the expansion. Which term is belong to that? We will find the r value, right? Therefore simplify NCR, write the constant part separately. 2 to the power n minus r, next word, minus 1 over 3 to the power r, okay, and now write completely x part is what? X to the power here, n minus r. If you take x square up, what happened? x to the power minus 2r. X to the power minus 2r. Therefore, NCR 2 to the power n minus r, and next minus 1/3 to the power r, but is totally x to the power, bases are same, when multiple at the power n minus 3r. This is very important, such a problems. Now we define the r value. Now they say independent of x. If we expand, no x terms in particular one term. Which term is that? That's the idea. So therefore in this question, this becomes 0. N minus 3r is 0. That means 1. It's power 0 means completely 1. 1 means constant term. X to the power 0 means constant term, right? Therefore we find the answer. So n minus 3r is 0. Therefore r equal n by 3. R equal n by 3. That means such a term consists of independent of x, no x value in that such a term, right? So n equal, what do you mean n equal 3? N is a positive number. And you can't take r is a 1.5th term, a 2/3 term, or minus 8th term. No, r is a positive integer. N also same, right? So take idea. Sometimes confused. Sometimes if you work successfully or some others confused, check with me. So here n become a positive integer. Okay. Not only positive integer, it should be a divisible by 3. Therefore, n is a factor of 3. Where you can write this, n should be a factor of 3. N should be a factor of 3. What is factor of 3 therefore? 3, and there's 0, 3, 6, 9. Like that you have to continue that. N is a factor of 3, right? So where n can be take a 0, 3, 6, 9 and so on. So one of this is possible to the answer. Now such a structure type problem, we can't take a long knowledge to apply this. Roughly or quick technique, use the tricky of the problem. Now we find which term is possible to collect the 240 over 9. So now you have the answer. So this is the answer of the coefficient. This is the answer of the coefficient of that independent of x term. So if I take n is no matter if n is 0, therefore if n is 3, n is 3, if n is 3 means r is 1. If n is 3, r is 1. 3 divided by 3 no r is 1. If n is 6, 6 divided by 3 r is 2. What happens if n is 3? 3 over 3 1, r is 1. N, so 3c1. 3c1, I will show briefly that part, not only for this question but also some other knowledge for your any future problems. If n is 3, I take if n is 3. Therefore r is 1, right? Now write the coefficient comes, let's check what happened. So n for 3. 3c1 2 to the power n minus r. 3 minus 1 2 minus 1/3 r is 1. This is, they say 240 over 9, but no negative, no chance. You can't take n for 3. You can't take n for 3. Why? Here minus comes. Minus 1/3 problem available. 240 over 9, no minus chance. Therefore n3 not valid. N is 6. Check and see n is 6. What happened? N is 6. If n is 6, 6 divided by 3, 2, r is 2. 6c2, 2 to the power n minus r. What is n minus r? 4. Minus 1/3 to the power r is 2. Here a chance for a square, positive, negative square, positive. So we'll simplify and see what happened. What is 6c2 value? Factorial 6. 6 minus 2, 4 factorial. This is 16. This is 1 over 9. Therefore, simplify. 6 into 5 into factorial 4 cancel. 2, 16 over 9. Cut the 2 here, 8. Yeah, check 240 over 9 available. 240 over 9 available. You substitute n for 6. If you put n for 6, therefore the answer n for 6. This is the method, right? How to connect this side here. You can find the n value and you can quickly substitute few values and you can check what the proper solution for the n.